All right, let's go. Number 7. The WOW signal. On August 15th, 1977, astronomer Jerry Amon was reviewing radio telescope data at Ohio State University when he saw something that made him grab a red pen and scrawl a single word in the margins. Wow. A radio signal had come through at 1420 megahertz, the exact frequency hydrogen emits. This matters because hydrogen is the most abundant element in the universe, and any civilization trying to broadcast across the cosmos would likely choose this frequency. It's the universal channel. The signal lasted exactly 72 seconds, the full duration the telescope could observe that particular point in the sky. It was powerful, focused, and it came from the direction of the constellation Sagittarius. Then it vanished. We've aimed telescopes at that spot hundreds of times since. Nothing. Silence. The signal strength was 30 times louder than the background noise of space. Natural phenomena don't do that with such precision. Comets don't broadcast at hydrogen frequencies. Stars don't pulse for exactly 72 seconds and disappear forever. What makes this truly unsettling is the narrowband nature. The signal occupied an incredibly thin slice of the radio spectrum, roughly 10 kilohertz wide. Natural cosmic sources spray energy across broad ranges. This was concentrated, deliberate. Critics argue it could have been terrestrial interference, a satellite glitch, something mundane. But every analysis has failed to find a prosaic explanation that fits the data. After nearly 5 decades, the WOW signal remains the strongest candidate for an intercepted extraterrestrial transmission we've ever recorded. Number 6. Fast radio bursts from a single source. In 2012, astronomers discovered something bizarre. Millisecond-long blasts of radio energy were hitting Earth from deep space. These fast radio bursts, or FRBs, are stupidly powerful. A single burst releases as much energy as the sun emits in an entire day, compressed into a fraction of a heartbeat. Most FRBs happen once and never repeat. Random cosmic violence. But then we found FRB 121102. This source, located in a dwarf galaxy 3 billion light-years away, repeats. It sends out bursts in patterns. Sometimes it's active for weeks, then silent for months. The pulses arrive in clusters. In 2020, researchers discovered the bursts followed a 157-day cycle with a 90-day active window. That's structure. That's regularity. Natural processes can be periodic, sure. Pulsars spin, stars orbit. But FRB 121102's pattern is complex in ways that make astrophysicists deeply uncomfortable. The energy output is absurd. To generate these bursts naturally, you'd need a magnetar, a neutron star with a magnetic field so intense it warps the fabric of space. But even magnetars don't explain the precise repetition and the specific clustering behavior. Some scientists have floated a hypothesis that sounds like science fiction. What if these bursts are energy leakage from a massive alien propulsion system? Imagine a civilization using directed energy beams to push spacecraft to relativistic speeds. The spillover radiation would look exactly like this: powerful, focused, repetitive. We're not saying it's aliens. We're saying we have no natural explanation that comfortably fits the observations. Number 5. Oumuamua's acceleration. October 2017. Astronomers spot an object tumbling through our solar system. It came from outside, from interstellar space. We named it Oumuamua, Hawaiian for scout. At first, everyone assumed it was a comet. But comets behave predictably. When they get close to the sun, ice vaporizes, creating a visible tail and a small thrust that alters their trajectory. Oumuamua had no tail, no coma, no visible outgassing. Yet it accelerated. As it swung around the sun and headed back into the darkness, it sped up in a way that defied gravity alone. The acceleration wasn't random. It was smooth and consistent, peaking as it approached the sun. Scientists scrambled for explanations. Maybe it was outgassing after all, just hydrogen or nitrogen ice we couldn't detect visually. But the math doesn't work cleanly. The acceleration profile was too specific. Harvard astrophysicist Avi Loeb proposed something radical. What if Oumuamua wasn't a rock? What if it was a light sail, a thin reflective sheet pushed by starlight, either derelict technology or an active probe sent to investigate our solar system? The shape supports this. Observations suggest Oumuamua is extremely elongated, roughly 10 times longer than it is wide. No natural object we've ever seen has proportions like that. It tumbled chaotically, reflecting light in strange patterns. By the time we realized how weird it was, Oumuamua was already leaving. It's now beyond our reach, hurtling back into interstellar space. We'll never get a closer look. Was it a bizarrely shaped comet with properties we don't understand? Or was it our first detected piece of alien technology drifting past our cosmic doorstep? Number 4. The Tabby's Star Dimming Mystery. 1,600 light-years away sits a star officially named KIC 8462852. Astronomers call it Tabby's Star, and it has been driving scientists toward existential dread since 2015. Stars don't just randomly dim. When a planet passes in front of a star, it blocks maybe 1% of the light for a few hours. Regular, predictable. Tabby's star dimmed by 22%. Then it brightened. Then it dimmed again, irregularly, asymmetrically. Some dips lasted days. Others lasted weeks. The patterns made no sense. You'd need something enormous, something half the width of the star itself, passing in front of it. But what? A massive swarm of comets was suggested. But you'd need thousands of giant comets all perfectly aligned all at once. The probability is absurd. Then there's the dust cloud theory. Maybe a massive cloud of debris is orbiting the star, occasionally clumping up and blocking the light. But if that were true, we'd see excess infrared radiation from dust being heated. We don't. The star shows no thermal signature that matches. This left one explanation that nobody wanted to say out loud. What if it's artificial? What if something was built there? In 1960, physicist Freeman Dyson theorized that sufficiently advanced civilizations would eventually construct megastructures around their stars to capture energy, a Dyson swarm. Thousands of orbiting panels, each blocking starlight, each harvesting power. If you were building something like that, partially complete, it would look exactly like this: irregular dimming, asymmetric light curves, no heat signature because the structure absorbs and uses the energy instead of radiating it away. Tabby's star forced astronomers to do something uncomfortable. They pointed radio telescopes at it, listening for signals. They found nothing. Follow-up observations in different wavelengths showed the dimming was more pronounced in blue light than red, which suggests dust after all. But even that doesn't fully explain the massive 22% drops. The star remains an open wound in our understanding, a question we can't definitively answer. Number 3. The WOW signal's silence. August 15, 1977. The Big Ear radio telescope in Ohio was scanning the sky, listening for patterns in the cosmic noise. At 11:16 p.m., it detected something that made astronomer Jerry Amen grab a red pen and scribble one word in the margin of the printout. Wow. The signal lasted 72 seconds. It was a narrow band radio transmission at 1420 megahertz, the exact frequency hydrogen emits, the most abundant element in the universe. If you wanted to send a signal that any technologically advanced species would recognize, you'd use that frequency. It's the universal calling card. The signal was strong, roughly 30 times louder than the background noise. It came from the direction of Sagittarius, near a group of stars with no notable astronomical activity. Then it vanished. The telescope never heard it again. For over 4 decades, scientists have tried to explain it. Was it a passing satellite? No, the frequency is protected for astronomical use. Was it a reflection off space debris? The signal's characteristics don't match. Was it a comet? A 2017 study suggested comets release hydrogen clouds that could mimic the signal, but other researchers tore that explanation apart. The math didn't align. Here's what terrifies astronomers. If it was a deliberate transmission, why only once? Why hasn't it repeated? One possibility is chilling. It was a beam, a directed transmission meant for someone else. And we just happened to be in the way for 72 seconds as the beam swept past Earth. We caught the edge of a conversation not meant for us. Another possibility is even stranger. It was a test, a single ping to see if anyone was listening. And when no one responded, they moved on. The WOW signal sits in a file somewhere, a printout with a red pen mark, representing the only time in human history we've detected something that could be a message from beyond. We've listened since, we've heard nothing. Either we caught a 1 in a billion fluke, or someone said hello and we missed our chance to answer. Number 2. Phosphine in Venus's atmosphere. September 2020. Astronomers announced they'd detected phosphine gas in the clouds of Venus. This wasn't supposed to be news. Phosphine is a simple molecule. 3 hydrogen atoms bonded to phosphorus. But here's the problem. On rocky planets, phosphine shouldn't exist naturally. It's extremely reactive. It breaks down quickly under UV light. To maintain detectable levels in an atmosphere, something has to be constantly producing it. On Earth, phosphine is created 2 ways. Industrially in labs, or biologically by anaerobic bacteria, microbes that live without oxygen. There is no known geological or chemical process on a planet like Venus that generates phosphine in the quantities detected. The discovery set off an immediate firestorm. Was this evidence of life in Venus's clouds? Venus is hostile. The surface is 900 degrees Fahrenheit with crushing atmospheric pressure. But 30 miles up, in the cloud layers, conditions are almost Earth-like. Temperatures hover around 80 degrees. The pressure is tolerable. If microbial life exists anywhere on Venus, it would be there floating in the acidic haze. The phosphine could be a waste product, a metabolic signature of organisms clinging to existence in droplets of sulfuric acid. Skeptics attacked the findings immediately. They questioned the data analysis, suggesting the signal was misidentified sulfur dioxide instead. Follow-up observations have been inconclusive. Some detect phosphine, others don't. The debate rages. But if the detection holds, if phosphine is genuinely present and being replenished, we have a mystery with no comfortable explanation. Either Venus has chemistry we don't understand, or life found a way to survive in one of the most hostile environments in the solar system. Number 1. The Fermi Paradox's Great Silence. This is the ultimate cosmic horror. The universe is 13.8 billion years old. Our galaxy alone contains 200 to 400 billion stars. Billions of those stars have planets in the habitable zone. Even if life is rare, the sheer scale suggests we should see evidence of other civilizations everywhere. We should detect megastructures. We should intercept transmissions. We should find probes. We've found nothing. This is the Fermi paradox, named after physicist Enrico Fermi, who famously asked, "Where is everybody?" The silence is deafening. One explanation is the Great Filter, a hypothesis suggesting there's a barrier that prevents civilizations from reaching the stage where they're detectable across interstellar space. Maybe that filter is behind us. Maybe life itself is the rare event, and we're alone. Or maybe the filter is ahead. Maybe every civilization reaches a point where it self-destructs, through war, environmental collapse, or technological misuse, before it can spread. If that's true, our silence isn't a mystery, it's a warning. Gigantic comets perfectly aligned in a configuration that defies probability. The infrared signature doesn't match either. If dust were blocking the light, we'd detect heat. We don't. Enter the megastructure hypothesis. Freeman Dyson once theorized that advanced civilizations would build massive orbital arrays to harvest stellar energy. If you were constructing something like that around Tabby's star, partially complete, with irregular panels and gaps, it would produce exactly this pattern. Asymmetric dimming. No excess heat because the energy is being captured and used. The structure absorbs rather than radiates. Scientists hate this explanation because it requires accepting something extraordinary, but every conventional model has failed. Follow-up studies showed the dimming is more pronounced in blue wavelengths, hinting at small particles like dust. Yet the 22% drop remains unexplained by any natural dust configuration we understand. Radio telescopes have listened for transmissions. They've heard nothing. Tabby's star refuses to give us a clean answer, leaving us suspended between natural mystery and the unsettling possibility of engineering on a scale we've never conceived. Please like the video and subscribe for more.